6-5 is all about multiplying our radicals together. So far we've learned how to simplify them. We've learned how to add and subtract, and now we're on to multiplication. So remember this property from 6.3, that we can either split things up or combine them in order to get things simplified. So if we take a look at our very first problem here, I want to multiply 3 root 2 by 5 root 6. So think back to x's. If I was multiplying 3x times 5x, we would multiply 3 and 5 together. And then we would also do x times x, which is x squared. So same thing with our radicals. Remember, adding and subtracting, you couldn't combine them. But when we're multiplying, you multiply everybody on the outside. So 3 times 5. And then you multiply everybody on the inside. 2 times 6. And then before we can box this up and say that we are all done, we need to check to make sure that nothing else can be simplified. So I'm looking at the square root of 12. That can be broken down. We can break 12 up into things that we either know, or we could make a little factor tree. I know that 12 breaks down into the square root of 4 times the square root of 3. Using this rule back up here. And now what I need to do is take the square root of 4. So I get 15 times 2 times the square root of 3. And then we can multiply 15 and 2, and we end up with 30 root 3. All simplified. So let's try the next one. We got a couple things on the outside, a 2x and a negative 7. So if we multiply those two together, we're going to end up with negative 14x. And then if we multiply the stuff on the inside together, square root of y times the square root of x times y, we're going to get the square root of x times y squared, y times y. And then again, we always have to check to see if we can simplify further. So inside of our square root, I only have one x, so he has to stay inside of there. But I have 2 y's, and we can make a group of those 2 y's, and they can come out. So we get negative 14x times the y we pulled out times the square root of x. Last one looks super scary because it has fractions and a bunch of stuff going on, but the steps are exactly the same. Take your stuff on the outside, so 15c, and multiply by the stuff on the outside of the other one. So 15 times 1/3 is just 5. We have the c. And then inside the cube root here, we have cd times cd squared. So I have 2 c's, and then I have d times d squared, or d cubed. And then hopefully it's clicking in that we need to simplify. Can't do anything with the c's inside of here because we only have 2 of them. But I have 3 d's, and since this is a cube root, I can take out one group of 3. And then I'm left with the cube root of c squared. And we're all done. So just like when we learn multiplication of polynomials, we are going to do just simple multiplication, like the problems before. We're going to do a little bit of distribution, like example 2 here. And we're going to do foiling, like example 3. So, when we distribute, we need to remember to multiply the stuff on the outside by everything on the inside. So if you want, you can rewrite it. 3 root 11 times 2 is our first thing. And then we're going to add 3 root 11 times the square root of 11. And now let's simplify them. We simplify the stuff on the outside of this first one. We get 3 times 2, which is 6, square root 11. And then the next thing here, the numbers on the outside are 3 and 1, since there's nothing there. And then square root of 11 times square root of 11 is the square root of 121. See what you can simplify. So the square root of 11 can't be broken up at all, but the square root of 121 can be. It is exactly 11. So we end up with 6 root 11 plus 33. Now on to FOILing. Remember, FOILing is just distributing twice. So the first thing I'm going to distribute is the square root of 5. Multiply these guys together and those guys together. So if you want to, you can write it out. We have the square root of 5 that needs to be multiplied by 2 root 5. Then we want to subtract the square root of 5 times the square root of 2. So if we simplify that, this first one gives us 2 root 25. And that can be simplified to 2 times 5, which is 10. And then we want to subtract the square root of 10. That can't be simplified, so we just get 10 minus the square root of 10. And that's only the first distribution part. Now we need to go back and distribute 3 root 2 to both of these parts. So again, you can write it out if you want to. 3 root 2 needs to be multiplied by 2 root 5. And then we want to subtract 3 root 2 times the square root of 2. So this first one here, numbers on the outside, 3 times 2 give me 6. Numbers on the inside give me 10. And then the next one, numbers on the outside, just are 3. And then root 2 times root 2 gives us square root of 4. So this 6 root 10 I can't simplify, so I'm just going to add it down here. But negative 3 times the square root of 4 is really just negative 3 times 2, or negative 6. And then using all of this simplified stuff here, combine like terms. So I have just numbers, 10 minus 6, that's going to give me 4. And then I have negative root 10 plus 6 root 10, so that leaves me with only 5 root 10s. So remember, all we're doing is FOILing. First, outer, inner, last, or you can think about it as double distribution. And if you can do this in less steps, more power to you. Example 5. Hopefully something you notice with these last problems, that if I multiply like the square root of 5 by the square root of 5, I end up with just plain old 5, because it's squared. And then when we multiplied the square root of 2 times the square root of 2, we ended up with just 2. So square roots and squares undo each other. So if I want to take the square root of 11 and square it, I'm really taking the square root of 11 times the square root of 11, which equals the square root of 121, and that is 11. From now on, we're just going to skip that, and we know if it's the square root and we are squaring it, we have 2 of them, we know it's just the number on the inside. And that's not just with square roots, that also works with cube roots, like this next one here. If I have the cube root cubed, that means I have it 3 times. And if we multiply all of this out, we would end up with exactly PQ, what was on the inside. So cube roots and cubes cross each other off. Square roots and squares cross each other off. Fourth roots and fours, blah, 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 blah. So now using that information, we need to address binomial things, 2 things with a square on the outside. Remember, you cannot just distribute that square. This first one, A, means that I have the square root of D plus 3 times the square root of D plus 3. Same thing that we did up here and that we did on problem 4, kind of combining problems 4 and 5. So now we need to FOIL. So if we multiply our firsts together, square root of D times square root of D, we really have the square root of D squared. And we know that gives us just D. And then after firsts, we do our outers. So square root of D times 3, we get 3 root D. And then our inners, 3 times root D gives me 3 root D. And then finally our lasts. 3 times 3 gives me 9. Always double check that you can combine, or that you can't combine, and we get this plain old D. You can't combine with anybody. But then these guys can. We add them up, we get 6 times the square root of D, and then plus 9 more. And that's it. I know we kind of wrote all over B, so let's rewrite it over here. This one I have 5 root y minus the square root of 2. So 2 square roots inside of here. But because it's squared, I know that really means I need to write this out twice. Don't distribute that square. And then do FOIL all over again. So this first one's kind of tricky. Remember, you have to multiply the numbers on the outside. So 5 times 5 gives us 25. And then if I multiply the square root of y times the square root of y, I'm going to get the square root of y squared. Now we know that those cross each other off, and it will just leave me with y. And I can do the same thing for the outers. Numbers on the outside, 5 times this negative 1 out here gives me negative 5. Then the inside, I have y times 2, so 2y. And then do the same thing for the inner guys. Negative 1 times 5 gives me negative 5 again. Multiply what's on the inside, I get the square root of 2y. And then very last, multiplied together, I have negative 1 times negative 1. Those are the numbers on the outside, so I'm going to add those. And then square root of 2 times square root of 2. If you multiply the numbers on the inside, you get the square root of 4, or 2. If you need to write out the square root of 4, be my guest. It's not going to take up that much more paper to make sure that you're getting the right answer. Make sure you watch your signs. People always mess those up. And then see what we can combine. And again, just like the last problem, it's the middle terms that can combine. So you get 25y minus 10 times the square root of 2y plus 2 more that I can't combine anywhere. And then because nothing else can simplify, nothing else can combine, we're done. Couple more problems. Example 7. We're going to do multiplication, just like we've been doing with the FOIL. But this time, we're going to multiply 2 things together that are kind of special. If you look on the inside of our parentheses, we have the square root of 3 plus 2, and then the square root of 3 minus 2. They're almost exactly the same, except for the signs. And when we have things like that, there's something called a conjugate. Conjugates will be pretty amazing in the next section because we'll need them in order to simplify some stuff. But awesome things happen when you multiply 2 conjugates together. So let's see what happens when we do that. So let's do our firsts. Square root of 3 times square root of 3. Remember, that means you have the square root of 3 squared, or just 3. And then we can do our lasts. Square root of 3 minus 2. So one's on the outside, one's on the inside. Can't combine them. And then do the inner guys. I get the same problem. Can't combine them, so I just do 2 times root 3. And then finally we do the last ones. 2 times negative 2 gives me negative 4. Take a look at our middle terms. These last 2 problems that we did back here, our middle terms were the ones that could combine. Same thing happened this time around, but our middle terms end up going away. I have negative 2 root 3's and positive 2 root 3's. So these totally cancel out. They make 0, and I'm left with plain old numbers, 3 minus 4, which gives me negative 1. Every single time you multiply a radical expression by its conjugate, you should end up with only numbers. All of your radicals should go away. They're either going to cross off like we saw right here, or because you have 2 of them, they are going to cancel each other out.